Please read this disclaimer in its entirety. Today we're going to learn about simplifying radicals. I'd like to motivate this by revisiting fractions. We know how to add two fractions with different denominators, but we don't normally think of them as not having like terms. That's really what's happening here. In order to be able to add them, we need to get common denominators because then those denominators become the like terms that can be combined. So we have this problem that you can't add two radicals together. These are not perfect squares, but they'd give us a little bit less than 9, a little bit more than 11. If I take the square root of their sum, I get something that's just a little bit over 14, which isn't even close to 20. Fortunately, we can multiply radicals together. If we examine this, we see that 3 times 2 is indeed 6, and we can use this to simplify the roots of large composite numbers. If we want to simplify a radical, we have a couple of methods. I'll start with the most basic, which involves creating a factoring tree for the number under the radical. When you write this down, you can leave out the radicals, but you should remember that they're there. Once the number is factored, we're going to look for pairs of matching numbers which would make perfect squares. Those pairs cancel out the radical so that you're left with a simplified answer. Notice that unpaired numbers still remain under the radical and should be recombined if there are more than one of them. If you'd like to go a little bit quicker, you can just factor out the perfect squares without factoring completely. If you're not confident in your factoring skills, you can still use the previous method. Once again, these perfect squares cancel the root, while the numbers that aren't perfect squares remain under the radical. Let's revisit the original addition problem to see how this helps us. Start by simplifying both radicals. A common mistake here is to continue to write the radical after you've taken the square root. Make sure that it goes away when you perform the operation it represents. You can see now that both terms have a common radical so they can be combined, giving us an answer that is indeed just a little bit higher than 20.